Okay, so let's go ahead and split the screen because I can't really show all the columns at the same time. I just need to show this much to, well, you know, for the time being. Are there any questions at this point? Okay. Let me just that will be fine. Okay. So now we can continue execution inside the subroutine called add complex, starting with line 9. Okay, line 9, really should not be a big problem, but it is kind of, strange because what are we going to do when we do something like this? Particularly, what does the assignment statement do? Let's look at the right hand side first. The right hand side is computing the sum of the I component of x and the I component of y. X dot I has a value of -2, y dot I has a value of 2. -2 plus 2 is 0. So the right hand side is just a value of 0. What are we doing with the value of 0? We are putting it back into result.i, or the I component of result. Result is not passed by value. It is not a local variable. It is a reference. It's a reference to column G to column H. So that means we have to look back into column G and column H and say, which one of you is the I component? Well, which one is the I component? Column H. So we go to column H and then we say, you are now updated to a value of 0. Line 10 is pretty much the same thing, except we deal with the R component. So the R component of X has a value of 3. The R component of Y has a value of 6. 3 plus 6 is 9. We store 9 back to the R component of what result refers to. So that will be column G. As a result, column G is now having a value of 9. In other words, the mechanism of passing by reference and changing the columns that we refer to by a parameter passed by reference, those have not changed. We are just extending those concepts to also deal with records. So now we are done with line 10. We go to line 11. Line 11 is going to deallocate all the columns. And in this case, we have 6 columns to deallocate, 1 for the return line number, 2 for X, 2 for Y, and 1 for the result. So now we indicate these columns are no longer in use, and then we go back to line 21. When we're back on line 21, we are also at the end of a subroutine, in this case the main subroutine. So that means we have to deallocate all the columns involved in the invocation of the main subroutine. Get rid of all of these. And then we go return to post. And the algorithm concludes. That's it. Do we have any questions about this trace? Because this is the first time we actually do a trace with records. And combining those concepts also to keep doing this. Apparently when I did that, it hit all the columns, so now they're all visible again. Any questions about this? No questions? Yep, go ahead.
A question about arrays and records.
Okay.
Arrays, or ages. Is that arrays, the variables inside of an array have to be the same type?
Yes. Yep. So that's one major difference between a record and an array. Every element in an array have to be of exactly the same type. If you have an array of integers, everybody has to be an integer. But with a record, you can combine things in a different way. You can have one Boolean followed by an integer followed by a Boolean again. So you can have any combination you want. And then the second main difference is when you deal with an array, each item inside an array is identified by a number. But in the case of a record, it is identified by the name of the component. Okay. Do we have any questions about this? No questions? Okay. If there are no questions, I will save this one first, and then we'll talk about we'll use another sample program to illustrate the concepts. So this one will just say it is adding complex numbers, just like that. And then we'll look at another sample program. This time, let's go ahead and combine the two concepts, arrays and records. Okay, we are not going to make anything that's too complex because it will just consume a lot of columns if I try to make it too complex. So we'll just have a record here, of a type. Oh, I don't know. Let's use complex again since we already know what it is. It's an R component, which is a number. Has an I component, which is a number, and that's it. And here we have a single subroutine. We just want the main subroutine here. Define sub main. And what we want to do in this case is to take a look at our local variable A. We'll say A is an array of 2 complex. In other words, this array has 2 elements, and each element is a complex number. And all we want to do is just to see how the columns are set up. We are not going to do any calculations. Well, okay, we'll do we'll do 2 calculations or 2 assignment statements. The first one is referring to the I component of the first element. We'll just give it a value of 3. And the second one will refer to the second element of the array, and the R component of that, and we'll give it a value of -1. Okay. This is not a complete initialization. I just want enough so that you can see how we can look at a particular component of an element when an element itself is a record. Okay? And define sub, invoke main. Are there any questions about the concepts of a record type so far? Nope. Okay. So we'll go ahead and see how we can set this up. So once again, we have line number. Once again, there's nothing to say about the precondition. We start execution on line 10. Line 10 doesn't really do a whole lot except to invoke the subroutine main, which means we need a return line number to tell us where to continue execution. It is post. That's the easy stuff. Now we need to specify the rest of the columns. How many local variables do we have? That's a trick question. Okay, how many local variables do we have? That's a question asking you not how many columns do we need. It is how many things do we have as a local variable. We have 1 local variable. Okay? The 1 local variable is A. Now, A is not a single thing. A is a fairly complex kind of thing, but nonetheless, A is considered a single variable. It has multiple components, but we'll get to the components later. You can treat A as a single thing. Okay, now that I know it has multiple things, what is the next level of stuff? Do we say A.I, A.R, or do we use A bracket 0 and A bracket 1? We use A bracket something first, right? So we say A bracket 0 is one thing, A bracket 1 is another thing. When we talk about components of an array, we refer to those things as elements. In other words, A is an array. I don't really care it is an array of what. Okay? But each item in array A is called an element. It has 2 elements. The first element is A bracket 0. The second element is A bracket 1. The type of every element in A is a complex, because according to this, A is an array of 2 complex numbers. So each element, A bracket 0, has an R component. A bracket 0 has an I component. Same thing goes for A bracket 1. A bracket 1 has an R component. A bracket 1 has an I component. Are we doing okay so far? So we first break an array into elements, and then each element being a record will be broken up into fields. Okay? In other words, when you look at R and I, they are referred to as fields of a record. That part depends on the programming language too. Some programming language will call that a property. You can call it an attribute. There are many names to refer to R and I as a component of a record. Now here comes the combination. Okay, so if I want to look at things as single things, so I would merge these two into one cell, because A bracket 0 as one thing has two components. A as a single thing consumes 4 columns all by itself. Are we doing okay so far with these concepts? Could you stop the popping, please? Okay, that's okay. It's just a little distracting. And now we can move into the subroutine. Oh, I forgot one more thing. What did I forget? All local variables start with unknown values. Now, I don't use just one single question mark. I have to use, in this case, one question mark per column. Okay? Because each column is a number, and each number is unknown. So that's why we have 4 question marks in this case. And getting on to line 7. Line 7 is easy because I have just spelled out what each column is. So column 7 is spelling out A bracket 0 dot I. Well, A bracket 0 dot I is column D, gets a value of 3. Line 8 specifies A bracket 1 dot I should get a value of -1. A bracket 1 dot I is column E, it gets a value of -1. Okay? And I did not even finish initializing the entire array A. Then we get to line 9, which is going to deallocate everything that we allocated for this invocation and return to post. And here we have a completely useless program other than the illustration of how to combine the concepts of arrays and records. Are we doing okay so far with this? Let's go ahead and save this program first, and then we'll have another sample program to illustrate how we can combine arrays and records, but in an opposite way. So this time we have records in an array. So the next one, you already know what it will look like. We have a record that has an array in it. So let's go ahead and start a new document. Close the other one. So this time we'll start with a record definition. And let's see. I'm trying to come up with an example, that somewhat makes sense. Okay. I'll deal with a queue data structure, and this is going to be something that I will continue to use next week. On next Tuesday, we'll continue to use this type of construct. And it has multiple fields. It has a field that I will call items. Items, not a single item. This is going to be an array of, let's say, I don't want it to be too big because otherwise it takes up too much space. I would say this is 4 integers. And then we'll have some additional fields. Let's say the next field is the head index, which is an integer, and we have a tail. Okay, we have a size. Which is an integer, and here we have the end of the record definition. And all I want to do